Thanks everyone for coming. Welcome to the Active Directory Botnet. So my name is Ty Miller. I'm the Managing Director of a security company in Sydney called Threat Intelligence. Done a lot of stuff with Black Hat. We run the Shellcode Lab training as well as practical threat intelligence. Done a number of presentations at Black Hat in different conferences over the years. Paul helps out with the practical threat intelligence training as well, and is obviously presenting today for the Active Directory Botnet. So what are we going to talk about? So we're going to demonstrate how to exploit a fundamental flaw in the way that nearly every organization implements their Active Directory, which is pretty much, a lot of the time, one big domain with a lot of the systems authenticating to it. And basically that introduces a gaping hole in our security that allows us to, or minimizes the ability for us to effectively contain security breaches. So this is achieved by turning your Active Directory, as the name suggests, into an internal botnet. And we're going to demonstrate live a number of features of this AD botnet, including getting some remote control over it. So I just wanted to sort of introduce this talk with sort of the current state of play. So the Verizon 2017 data breach investigations report, shows that it's not going to be a surprise to everyone here that attacks and breaches are going crazy these days. And when you start having a look at some of the statistics that they pull out in this and they categorize it, there's obviously a lot of stolen creds that we're seeing through dumps coming out pretty much every day or week. But the interesting ones, or for us anyway, for this talk, is the use of backdoors / command and control. And you can see on the right-hand side under the fin column, there's 557. So the red ones there are really the high numbers. And that's typically related to things like your malware and also down the bottom there you can see with phishing. So we're combining it with your client-side attacks and your command and control. So this is just to give you an idea of some of the ransomware revenue that has been seen over the last few years, with a lot of them netting over 100 million, and the expected or estimated amount in this year was almost $1 billion. So there's huge amount of motivation for these attackers to be, compromising your internal network and setting up a command and control environment. So some of the primary attack techniques, as I was saying, is you can see on the right-hand side is the phishing. So it's through the social engineering or phishing with client-side exploitation, drive-by downloads, or just, your lucky HR lady clicking on the attachments. So then you can see that in this second bullet point, phishing remains a favorite technique of attackers with payloads commonly delivered via email, 73%, and drive-by downloads, 13% for that particular category. And if the attachment, so in terms of the functionality of what actually happens then, if the attachment's then opened, it'll drop a command and control malware, and then obviously set up that backdoor communication channel back out to the CNC server. So currently attackers are still trying to be pretty stealthy, right? A lot of this malware tries to hide. I tend to suspect that, with a lot of push towards automation, like in security as we see, there's a big push towards automation and machine learning and those sort of things, and it's only a matter of time before the attackers sort of catch on to that and start automating a lot of these attacks for, we sort of, or people outside of this room probably got surprised at things like the big malware hits that we've been seeing recently. But if we start if attackers decide to start removing that stealthy part of it and just going nuts, we're in big trouble. So, as you start to see open source technologies evolving, the software and the attack capabilities are just going to become huge, especially as, the machine learning side of things really matures. So the other thing is that I really find surprising is, not surprising that people are moving to the cloud, that's obviously a norm these days, but just, we're really extending our internal networks out to the cloud. And we tried to take advantage of that within this presentation to leverage the fact that, we've traditionally built up this hard shell of a traditional security architecture, but then cloud has suddenly just ripped that apart and started throwing it out on the net, right? Which I think a lot of people in this room tend to struggle a bit with. So there's huge potential for attacks to break out of your organization, go noisy, and really perform some fast escalation and large impact attacks. So basically, just to summarize that, we're looking at highly motivated threat actors utilizing endpoint exploitation techniques that connect to command and control servers to launch fast and effective internal attacks. So the main challenge is for these attacks, is to reliably connect out to these command and control servers. And so what we're trying to do is sort of make people realize, what the next generation of attacks might look like. So start thinking about things like, what if command and control server exists inside your internal network? What if the C2 server exists as a part of your critical infrastructure? How are you going to deal with that? What if the command and control servers start using your production services for their communications rather than trying to tunnel out by their own connections? And what happens when your command and control servers inside your internal network can bypass all of your firewalls and all your network access controls by using your production services? And the other is, as I was saying with the cloud comment, what if your command and control servers start tunneling out via your cloud connections, which we've just opened up to allow functionality and flexibility? So, introducing the Active Directory botnet. We're trying to achieve those things. So first of all, I just wanted to start off with having a look at a common Active Directory architecture. So this is sort of a picture of a common organization. You might have a DMZ, you may or may not have a domain controller in there. You've got your cloud DC on the right there that may have a cloud domain controller in there. And then you've got your various different security zones, which may be your WANs or your various network segments. And they may have their own domain controllers in there as well, right? And you can see each of the domain controllers can talk to each other, as well as out to the cloud. And each of these systems in each of the different security zones can talk to the domain controllers, but not talk to each other. But the domain controllers can talk to each other, right? So let's have a look at a common botnet architecture. Wait a minute, that looks very familiar. Active Directory, botnet architecture. Active Directory, botnet architecture. So you've got, in this case, you've got different organizations as represented by the circles. And you don't necessarily need the command and control servers inside the organizations, but there's command and control systems on the internet, and within these different security zones or organizations, there's bots or communicate with the command and control systems, including bots sitting in the cloud, right? So what we're doing is combining the two similar concepts for a bot architecture and an AD architecture and creating the Active Directory botnet architecture, which is pretty much the same as both, right? So you've got your domain controllers in the middle. You've got different systems within your environment that have been infected by bots. And as we just went through the state of play, you know, a lot of these we're seeing a lot of security breaches, and a lot of these breaches are coming through, you know, your client-side attacks, and therefore it's quite likely that you'll actually get systems spread across multiple security zones getting breached, but they can't necessarily communicate with each other. So what the Botnet, Active Directory Botnet architecture does is actually allows all of those bots to talk to each other no matter what security zone they're in. Okay, so suitability of Active Directory as a command and control channel. It's a central authentication and access control point for organizations. So, you know, a lot of organizations will use AD as their central authentication, and therefore, you know, if system administrators want to log into, you know, a server in the DMZ, then it has to be able to connect to their Active Directory. If they want to connect to a system that's in their corporate VLAN, it has to connect to Active Directory, right? Or if they want to connect to another system in a different security zone, it has to connect to Active Directory for authentication. So all the end user devices and a lot of the servers will connect to AD, which means that we can utilize that connection to bypass all of your network access controls and all your firewall rules, because that's got that gaping hole where everything can communicate with this one central place. So the other thing with Active Directory is that any standard user account can write to their own attributes, right? So when we're talking about Active Directory and its suitability as a command and control channel, we need to be able to send and receive data so that we can get a two-way communication channel. So users can write to their own attributes, and they can read other users' attributes, which means that we can write data and we can also read data from other bots, right? So that allows a two-way communication channel through your domain controllers to be able to talk to any other system within your network. As well as when you start looking at you know, cloud systems, you can communicate out via through AD to your cloud systems, and we're also going to show you how to utilize your cloud domain controllers to actually exfiltrate data out of your organization. So I'll hand over to Paul. He's going to step you through the gruesome details. I'd just like to give credit to Paul. He has been working hard for a long time now. He's done about 90% of the code in this. So good work, mate.
All right, thanks. All right, so yeah, as Ty's been saying, like one of the interesting things about using Active Directory for the command and control is that it basically turns whatever network you've got, no matter what segmentation or what network controls you've got in place, it turns it from, you know, a segmented network into more like a star-based network where, you know, at the center of the star, you've got the domain controller. So basically, every little node connected to it is able to access and read data from the domain controller, and, you know, in that manner establish a two-way connection. Now, another interesting thing about it is that the kind of traffic that you'll see when you actually run traffic over it, there's really only, you've got obviously Kerberos for authentication, then all the updates to attributes go over the ADWS, which is like, you know, the Active Directory web service, which is encrypted, you know, SSL. And so, you know, it's not something that's easily viewable over, you know, like if you've got like a intrusion detection system or something like that on your internal network, it's not something that's going to be easily visible on any of your network detection mechanisms. The other thing is that the normal default logging on Windows in Active Directory typically is not going to detect it either. the kind of logs which will be generated are typically the type of things like Active Directory object updates. And most people, even if it is turned on initially, will turn it off because it's quite a noisy sort of event to be looking at, because like there's so many updates to Active Directory objects. So there's just a couple of things just to set the scene about what makes this kind of command and control network interesting from an attacker's perspective. So, like, there's a lot of standard user attributes. Not all of these are writable to the average user, but like a subset of these are usable. And so, like, they range in size from about a megabyte down to about 64 bytes or something like that. I can't remember the lowest one, but like the largest attribute's about a megabyte from memory. So basically, you can use any of these attributes for establishing the communication within the network. Oh, here we go. Here's some of the sizes. So the largest one is the MSMQ sign certificates. It's around about a megabyte, and you've got thumbnail photo and a few other ones. So basically they're divided into like binary attributes and string attributes in terms of their type. So where's the next one? So in terms of establishing our botnet, the way we sort of did it is when like a node or a bot registers, one of the first things it does is that each botnet's got like a unique GUID. And so what it would do is as part of its initialization routine would be to update the IP phone attribute with this GUID. And so what that means is that like when we look at the botnet, we can scan the entire Active Directory for that GUID and look at only those systems in which that GUID matches the botnet GUID, and then we can actually track the nodes that we've actually got infected on the domain. And so then we know which ones we can establish commands and send data to, receive data from, start reverse shells, bind shells, all that sort of stuff. The info attribute is one we chose for a control channel. So we sort of established quite a simple protocol. And basically, when we're looking at differentiating between nodes within this network, the main thing we're looking at really is the user account that has been compromised, and also the host name that it's running on. Oh, one other thing that I forgot to mention before was that before when we were talking about the in terms of why it's a good channel, is because we're not actually establishing any login events. When a user runs this this bot, basically it sort of tags onto their own credentials, so you don't get logon events. So that's just another thing that's interesting. So the info attribute is what we use to send command and control. And then other attributes we use as data channels, so for sending data and such. Oh, here we go, bot registration. So, yeah, as I said before, the GUIDs with the IP phone and the command outputs through other variables. Okay. So there's a graphical sort of representation of the registration process. So you've got the GUID and the info attribute, and it sort of sets itself into like a waiting state. So basically, we've tried to make it quite stateful. So when it initially sets itself up, it gets into like a wait state, waiting for instructions, and other nodes can communicate with it when it's in that state. But when it's actually operating on an instruction, it goes into another state. And then the other nodes have to wait until it gets out of that state before it can communicate. Okay.
List the bots.
Okay. You want to do a demo or?
Not yet.
Not yet? Okay.
It just keeps going through each of the different
All right, so some of the functionality we've got within the application is, like obviously we want to know which nodes we've got infected in the network. So like we've got like a controller which we can set up, which can actually deliver commands throughout the network. And so one of the things we can do is actually list all the nodes in the network who are actually infected, so that we can then direct commands to them. So we can we can display the username and the host name and stuff of the systems which are infected. So basically this is really what happens, you know, like we've got numbers of different hosts on the network which might be infected, and they might be all in different security zones, and we can see from our perspective of the control panel, we get a listing of each of the nodes, the user accounts which are, you know, affected, and also the host name of the box that they're running at. Really, we've got that there because obviously with multi-user systems, you could have multiple users on the same box which are infected as well. So I guess the initial stages when we started testing this, the first thing we obviously did was to set up functionality to send commands to the bots. So from the controller, we can actually control that and send numbers of commands. I mean, the way that it kind of works is we've got like the protocol. We've got like the username, host name. We've got then the type of command that needs to be run. And then we've got the destination user and host that the system's going to be run on. So what happens is that each like node can only really write to its own properties, but what it does, it writes to its own command and control attribute, which is the info attribute, and it says, you know, this is like the destination host that I want to run the command on. Each of the other nodes will be polling AD, looking for commands which are being directed towards them. And if it sees within somebody else's info attribute that it's saying, look, I want you to run a command and on you, then it will grab the command from that other attribute, it'll run it, and then send the command attribute, or the command output, sorry, to that node. So that's basically what happens. So yeah, basically, you know, all of the output and commands are all encoded in base 64 just to make it safer and, you know, prevent, you know, issues in the delivery of the data. Yeah, so then basically we've got the initial sort of commands are just like running a single command. We've got like a simulated shell, which is just basically just a send command that loops around and just allows you to simulate, you know, a shell on the remote system.
See through what you just spoke about.
Oh, okay.
So this just steps you through just graphically each of the different steps and the type of data that is being passed through the attributes for the commands to be run.
Yep. So then the next sort of commands we sort of looked at, because we thought, you know, people put security boundaries in place to stop, you know, files being uploaded and downloaded from systems within the network, you know, because you might have highly sensitive information in a, you know, highly segmented network. So what we then did was we set up a functionality so that we could do file transfers using the attribute. So basically, it's just basically another type of command within the command and control channel, and it just uses different attributes, normally larger attributes, the ones that are the larger in size, like the SQM sign certificates is a good one for delivering files and stuff, because it's 1 megabyte in size. And so basically it just works by, in the same way, just by cutting the file into the chunks, which are the size of the attribute, sending them through. The node on the other side will receive a packet, then it'll acknowledge the packet. Like the node on the other side will not send the next packet until it receives an acknowledgement, and then it goes like that until basically the entire file's been sent through.
All right.
Okay, so we'll do a bit of a demo. Which one is it? This one. So this one here is like the command and control.
Make it any bigger. The text.
Oh, okay. How big is it on? Oh, it's quite good on there, I think. So basically what we can do, we can, as I said before, we can list the members of the botnet. So you can sort of see there that we've got like a few users there, staff 1 on Win, whatever that is. We've got staff 2 and staff 3 and staff 4. So each of those systems has got a bot running on it. So now that we know which ones are infected, we can actually send a command through to one of the nodes.
So these systems are actually in different security zones, and they can't communicate with each other directly, so they have to go via AD.
Yep. So then what we can do, I can select one of these bots to be sending commands to. So we'll select the second one. And we'll enter the command. So we can see that the user's called staff 2. So what we can do, we can enter a command. We can say, look, I want to get a listing of this user's downloads directory. And you can see this is the sort of commands that are sort of going through in the protocol. We sort of printed them out so you could see it. And although it's hard to see in all that sort of command output there, you can see that in the users directory just here, there's a couple of files. One's like creditcard.txt. And so what we can do now, I'll download that into my download directories on this machine, using the functionality within the bot. So we want to grab it from staff 2. And we'll just stick it in our downloads directory. So basically that will go away and upload the file. It should pop up in this directory, hopefully. There we go. So you can see, through the network boundaries, we can, upload and download files and do all that sort of stuff through that. Yeah,
Sure.
Move on to the next part.
All right, thanks, mate. So now you can see that we can bypass all the network access controls and your firewall rules just by tunneling everything through AD attributes and be able to even transfer files around the network. We also looked at trying to see what options we have with Azure AD, which Microsoft provide an Azure cloud-hosted API into your Active Directory, which is known as Graph API. So this basically lets you interact from the internet through an API directly to your Active Directory. So that basically exposes your AD to the internet, and you can access that as any standard user within your organization. Which means that we were obviously looking at trying to get a two-way communication channel from the internet via this. Unfortunately, a couple of years ago, they disabled the user attributes syncing from Azure back to your on-premise environment. So that unfortunately stopped us from getting the two-way communication channel through that. However, it does obviously allow on-premise AD attributes to be synced to the Azure AD and then accessed through the Graph API, which means that if you get your internal AD botnet, you can then have your botnet start grabbing data such as these files, pushing them into particular what we call exfiltration attributes. They get synced up to Azure AD, and then we can, as a standard user account, just start extracting those directly from the internet via Graph API. So we've got a feature called exfiltrate data. So as I said, the botnet pushes data into an attribute, syncs it to AD, you authenticate as a standard user to Graph API, you list out the user attributes, and then you can grab the values from those to basically keep pulling all your data out. So you can see the exfiltrate data option there. So this is just a graphical representation of that. So you can see that the bots can obviously communicate with the domain controller and it sends it out via Azure. And then the attacker, pretty guy in the top left-hand corner there, can obviously connect to Graph API and then pull that out. So since our two-way communication channel got shut down through Azure AD, we then wanted to have other command and control options. So we implemented an AD botnet reverse TCP handler, and basically what this does is it allows you to have, if we go back to, I guess this, you could have, for example, your bot on the left-hand side issue the command that he wants to establish a connection back to our attacker out on the internet via a TCP channel. At that point, on the bot on the left-hand side, he basically sets up a socket, and he can say, I want to port forward this socket through Active Directory to the bot on the right-hand side, as if it's just a TCP connection, and then can issue that bot on the right-hand side to start connecting to any other system in its network. So it basically bypasses not just your internal network access controls, but basically exposes a socket from the guy out on the internet through to a socket on your internal network through different machines and through your Active Directory. The other one is the reverse. So you've got your bind TCP handler. So the connect back obviously connects to the internet. if you've got outbound firewall rules preventing that from connecting out, but you might have, for example, a bot within your DMZ that's compromised and you have an open port through your firewall, which is quite common. If you run an Nmap scan and you get a closed port, then obviously the bot can set up a bind port on there so that you can establish a TCP connection from the internet to your bot. And again, that basically just port forwards that socket to any system on your internal network. So let's try and do that live. All right, so we've got our bot here. And sorry about the size. I won't mess with it right now. It's not overly important. But there's basically two options there. One is that we're talking about. One is the bind handler, and one is the reverse TCP handler. So we're going to start with the reverse TCP handler, which is number 7 here. It again lists out the bots and says, which bot do you want me to forward this TCP channel through AD to? So it lists out your bots, and I'm going to say, I think it was number 1. Do you remember what we were logged in as? 2. Yeah, let's go with number 1. All right, so then it asks us for our controller IP. So where do you want to connect back to? And it's called controller. What port do you want to connect back to on the controller? So in this case, we're going to do 4444. So the target IP is, so we've already said that we want to open up, port forward this socket through AD to this bot number 1, which is in a completely different security zone, right? So our target IP can either be a listener on that machine, or it can be another IP address within that network. So we're just going to do on that machine itself. So we'll do 127.0.0.1, which is the local host of the remote bot. And the port that it's going to be on, which is 4444. Before we kick this off, we want to obviously, on our controller on the internet, we want to set up a listener. So we're going to use Metasploit for that. Oops. Options. There we go. So we're going to use the Metasploit multi-handler to set up a 64-bit reverse TCP handler. And that's basically just going to accept our TCP connection, drop us to a Metasploit session. So we've started up the Metasploit listener. If we then hit OK, we've now established a connection to our remote attacker from our internal botnet. If we then type a command, you'll see same sort of thing as Paul was demonstrating, all the different pieces of communication going past. And there's our shell. Right, so you can basically, that's a full shell that you can just keep interacting with over the internet via an internal bot, via AD, to any system on your internal network. And again, that'll just be throwing the data back and forth. And there we go. So if we kill that connection, our bot controller then drops back to wanting to ask what we want to do. So in this case, we're going to now set up a bind handler, and this is to demonstrate the inbound connection. So if we type number 6, which is launch AD botnet bind handler, again, we're going to select bot 1. We're going to bind to, this would be the port that, if you've done a port scan against your external IP address and you find a closed port on one of your bots, then you can get it to set up a Active Directory botnet bind handler on that port. And then we can basically as I was saying, that basically opens up your internal network to any of your hosts. So again, we're going to do 4444. Hopefully you guys don't open your firewalls up on 4444. Again, we're going to use the same host and the same listener. So we set the target IP, which is the remote bot internal to the organization somewhere, set up the listener on its own network. And it's now sitting there saying accepting connections from the internet, basically. So if we go back and we set the payload to be a bind TCP, and type again. There we go. So we're going to connect from the internet to our Active Directory botnet on the port that we've specified. So it's just going to establish a TCP connection to it. Immediately drops us to a prompt. What every attacker does, they type dir because they want to see the listing, right? That's the most valuable thing inside our organizations. So you can see that, again, it's made that connection. It's going through AD to the internal bot somewhere. We don't even know where it is from the internal attackers, from the bot controller's perspective. And you can see the big dump of data up there. And again, we've got a remote shell through AD to somewhere on our internal network, no matter what your network access controls are. Okay. So how do we actually go about mitigating the Active Directory botnet? So as Paul was mentioning before, in terms of logging, there's basically zero. By default, it doesn't log updating your standard user attributes because there'd be a lot of logs, right? Setting that sort of logging is obviously an option. Separating your domains into different security zones, which I know that a lot of organizations, especially with critical infrastructure, have multiple domains for the different critical security zones. But I've even spoken to some of them recently, and they're looking at collapsing it just for management reasons. So hopefully this stops them from doing that. And obviously noticing odd values that are being pushed into your standard user attributes. So you start seeing your IP phone with GUIDs in it, or your notes, which is the info attribute, with these command and control data, then that's obviously a warning sign. The other is that you can actually lock down your permissions for standard users to actually update their own attributes. Whether you actually want to do that or not, but I don't often go and change my name in AD. So thank you very much for coming. If you have any questions, we're keen to hear your thoughts, but thank you.